So, following on from adding and subtracting with standard form, I gave you this one to have a think about. Subtraction. So, who would like to talk me through it? May.
So what we would do 10.2 times 10 to the power 4 instead of 1.02.
So 10.2 times 10 to the 4. So this one changes. Okay. And then minus 2.03 times 10 to the 4. And you did that because?
That one's easier.
And because we have to have the times 10 has to be the same, yeah. Okay. And you chose the bigger one because it was easier for you to do. Okay. And now what are you going to do?
And then you take away 2.02 from 10.
So do 10.2 subtract 2.03.
I put a month and that's 8.17.
Okay, so can I do that across? So
I subtracted
so I've done that. So actually 10 take away 3 is 7. 1 take away 0 is 1. 10 take away 2 is 8. So 8.17. So we end up with 8.17 times 10 to the
4.
times 10 to the power of 4. Is that in standard form?
Yeah.
Yeah, so we don't need to do anything.
What is standard form? Will it have? I don't know. That was an accent. Sorry. Will I ever go to like Will you have to work it out?
What, convert it to a normal number?
Yeah.
Potentially.
Because I thought the whole point of standard form was to make it easier, right?
Yeah,
But
exactly.
some might say to expand it.
Well, it's a skill you have to have. You have to be able to convert between ordinary numbers and standard form. But, for instance, there will be questions. Standard form questions tend to be application style questions rather than just do these things. So, for instance, it'll be something to do with the circumference of the Earth and the distance away from the Moon and the speed that light travels, or those big interstellar distances that have to be written as standard form. And for instance, the same with any measurements. We can convert kilometres to metres, and we have to be able to do that with the number in standard form. So you either do it in standard form or you have to convert it. So for instance, if I were to just make up a number there and say 3.5 times 10 to the power of 17 kilometres, okay, between one star and another, okay,
It always picks an odd number.
how many metres would that be?
3.500.
So 3.500 metres. So we've got 3.5 times 10 to the 17 kilometres, but only 3.5 metres.
10 to 17 as well.
Okay.
But 3.500 is the same as 3.5.
Oh, it is.
Do you see how the shortcut of adding zeros that someone told someone
Doesn't it mean the
has just
same?
messed up an answer and cost you marks?
3.5
That's why I try and get rid of these shortcuts.
Mr. Boss.
So,
Mr. Boss.
please don't shout. Right, so that was not correct. So let's have a look. What method do I actually have to use to work it out in metres? What do you do? Oh, if you're going to be like that, no.
I put a smile on.
Well, you know that. Okay, so there's 17. So it's 10 by 17. And you know that there's already one place after the decimal point. So that means that you would add 16 zeros, because altogether that would be 17.
Add 16 to... But all I want to know is how many metres is that? That's all I want to know.
Oh.
Are you going to be polite now? And okay, go on then. Explain.
Well, when you're changing kilometers to meters, you know that you're timesing by 1,000. which is basically timesing by 10 to the power of 3. So you'll do that times 10 to the power of 3, which is 3.5 times 10 to the power of 20.
Okay, so we've got 3.5 times 10 to the power of 20 meters. So, like, times it by 10, 17 times by, okay, all right. So you could convert it into a normal number with how many zeros?
16.
16, yeah, the first number, right? And then times it by 1,000 means add 3 more zeros. You could do it that way if you like, but it's just not necessary. And as good mathematicians, we want to be able to do things as quickly as possible. Okay? So if I were to give you a problem like a space shuttle, right, travels at 4 times 10 to the power of 3 meters per second, okay, and it wants to cover a distance of 2 times 10 to the power of 11 kilometers, how long would it take? So this would be its distance, this is its speed. So how long does it take? Now I'm not going to take answers now, I would like you to have a think about that. And even if you can't do it, I want you to think of a process. If you want to chat to the person next to you, offer her your solution. How long does it take?
Wait, hold on. Speed is distance divided by time, distance divided by speed.
Okay, so we've got this rocket travelling at, I've just made these numbers up, I have no idea whether this would be reality or not, but that doesn't matter, it's how we use our numbers in standard form. So we've got 4 times 10 to the power of 3 meters every second is the speed they're travelling, okay? And it covers 2 times 10 to the 11 kilometers in distance. And we've got to figure out how long it takes, right? Now, a number of you have, well, you thought straight about the triangle. So just to confirm that, if you're thinking about it, do you remember this triangle from physics?
Speed, distance, time.
Yeah. So how do we do it? Speed equals distance over time, if that's the one you want to use. I just, like I said, the common sense for me is if it's 4 times 10 to the cube meters every second, then if I divide my distance by how many meters I do every second, I get the number of seconds. The trouble with this is, like they tend to do, is, well, what's the first issue? Yes?
That's kilometers, not meters.
Yeah, exactly. So we've got meters here and we've got kilometers here. So we have to have the same unit for a start. You can choose whichever one you want and change it to the other one, it doesn't matter. So which one do you want to do?
Kilometers.
Kilometers into meters.
No.
Yeah.
Yeah, Sophia wants to say it. Okay, so let's change, okay? Let's change the distance into meters. So we've got 2 times 10 to the power of 11 kilometers. What do we do to turn kilometers into meters?
Times it by 100. 1,000.
1,000, which we could do by doing timesing by 10 to the power of 3, keeping our methods consistent. So that would be 2 times 10 to the power of 14
Wait, no, that's wrong. 'Cause you
meters.
have them.
Okay,
That's 15.
No.
Oh, sorry.
okay,
11. Yeah. that's
okay. So we've got it in meters now. Then what do we do? Sophia, do you want to carry it on?
I think I got it wrong. I think
Did
I
ya?
was calculating instead of added.
Okay. So what do we do now? We need to do the distance. Okay. So we've got this amount. We need to share it between how many meters I do every second, yeah? So don't I do 2 times 10 to the power of 14 divided by 4 times 10 to the power of...
3.
Are we sure?
Yeah.
Alright, so we've got 4 times 10 to the power of 3. So that is our number of meters divided by our meters per second. And I remember being told this by my physics teacher, so just in case he's listening, Mr. Galloway his name was. I have no idea, probably not. I don't think I'm that old. I used to be on the Isle of Wight. He used to cycle, catch the ferry every morning, much bigger. But he helped me with this. And if you look at the units, well, this is like doing meters divided by meters over seconds. How do you divide by a fraction?
You put it over one.
You turn around, so you do meters times seconds over meters. If I do that, what am I left with?
Seconds.
Meters cross out, I'm left with my seconds. So that tells me this result will give me something in seconds. So you can always look at the units to see whether you've got the numbers the right way around. And that's what I want. Okay, so we've just got to be able to do that now. So yes.
So that would equal 5 times 10 to the power of 10.
Well, let's do it to stage so we can simplify. So this was the division bit I wanted to do with you, the dividing with numbers in standard form. So we do the 2 divided by the 4 is a half, which is 0.5. So I'm going to write that because actually this is one of those situations where decimals are better than fractions, which we don't, right? Because we've got 0.5 times 10 to the power of. So we've got a division using
14
indices.
subtract 3.
14 subtract 3 is
11.
11.
How did you get 10?
I think some ones that I checked, you did the division the wrong way round and I didn't spot it. But this answer is a number of seconds, but it's not in standard form. So how can we convert that to standard form?
Oh, the decimal.
Take one of the 11s away.
So it's 5 times
10 to the power of 10.
12. Because I'm going to do it the long way again, just to explain to anyone. The 0.5, okay, is it 10 or is it 11? It's 10. Because we've got 0.5 is the same as 5 times 10 to the minus 1. And then we've got the times 10 to the 11. So this then becomes, what do you do when you are multiplying with the powers?
You add them.
You add them, so you've got 5 times 10 to the power of 10. So
Yeah, I was right.
you were right.
Yeah.
So that's your seconds.
Yeah.
Yeah.
You told me I was wrong.
Oh.
No, I did not.
Yes,
I
you
said I
said
asked.
five.
I asked.
Right.
You like no.
That's our number of seconds, right? Let's see now whether we can go. Well, do you notice how we did that question with no calculator? There was no calculator involved there at all. Let's have a look though. So we've got that many seconds. Now I'm not waiting for you to write it down slowly and right. We've got the thought process going on. It'll be on the video later and posted on Firefly. You can copy your notes down, no problem. Okay? Or I can put it on afterwards. How do we convert a number of seconds? So this is our number of seconds, but I need it as a time in hours, minutes, and seconds. Which is going to be hard because it's standard form.
Wait. Question.
Yeah?
Random number. Could you have 3 times 10 to the power of 20 seconds?
Why not?
Okay.
Have what you like, can't you? It's a long time. But we've got a very long time here. 5 times 10 to the power of 10 seconds. We've got to convert into hours and minutes. So what's the first thing you do? So you go from seconds, you convert to minutes, and then you convert to hours. Okay.
Okay. can I guess?
No, I don't want to guess.
Well, it's more, this is what
I want a
did.
process that is correct. We might not know the answer. We can work it out.
I have a process.
Go on then.
Okay. So since there are 60 seconds in a minute,
Yeah.
I did 5 times 10 to the power of 10 divided by 60.
Okay, so do we all get that?
Yeah.
So we do 5 times 10 to the power of 10. That's divided by 60. Now, all right, divided by 60. And then the answer to that is then divided by 60 again to get your hours. We'll do it like that. Are you okay with me writing like that?
Yeah.
Yeah. So that's like doing 5 times 10 to the power of 10 divided by 3,600,
Wow.
3,000, which is, I did see you doing this,
I did.
5 times 10 to the power of 10 divided by 3.6 times 10 to the power of 3? Yeah, you okay with that?
I
So
got
now
it.
our answer is, well, it's going to be times 10 to the power of 7.
Is E 10?
Okay. What's 5 divided by 3.6? You can use your calculator for that.
1.389.
What?
1.3. No. Yeah. 3.
1.3.
8.
9.
Should we just do it to
Three
three significant figures, shall we?
3, 9.
3, 9.
It's not too long.
Okay, should we just do that?
What's an E?
Right, so that's a good point actually. On your calculator, it's a good thing. If your calculator says this, what that means is 5 times 10 to the power of 10.
Oh,
So 5e6 means 5 times 10 to the power of 6.
so
Now this is notation that the calculator uses, but you should never write that down. So when you do a project or something in IB, if you write that, you'll lose marks. So that's calculator notation. It's not proper mathematical written notation.
E equals
So the
10
E
times
is
times 10.
times 10 to the power of whatever the number is. So that's how to interpret your calculator. Just never write it. Don't write it in your book. Don't write it in an exam paper because you won't be credited with it. Don't write it. Just understand it. So we've got that many hours. Yeah?
Wait, so you never got your minutes then?
No?
You did both, right? So would you divide that by 60?
So let's say you look at the 1.319, so you know you have 1 times 10 to the power of 7 hours plus 0.39 times 10 to the 7 to the power, so you know you have 1 times 10 to the power of 7 hours. And then you take the 0.39 times 10 to the power of 7, and then you try to convert that to minutes, because that's what's left, so you try to see what minutes.
Sort of, but why do you do, it's the kind of understanding of this notation. If I told you it was just 1.39 hours, okay, the problem was that some people would go, okay, that's 1 hour 39 minutes. Yeah?
I was going to say that.
It's really not, is it? But what it is 1 hour 39 out of 60 minutes, because we've got less than a whole hour. But in our notation and in our size of things, do I have less than a whole hour?
No. Yes. There'd be
No.
99 minutes.
So I've not got 1.39 hours. What do I have? 1.39 times 10 to the 7 hours. And what's 10 to the 7?
10 million?
10 million.
10 million hours?
So I actually have
That's a
One.
long rocket.
lot of 10 million. So I have 10,390,000 hours.
That's a
So I actually already have a whole number of hours. I don't have any minutes and seconds to worry about, no? Tricky or testing your understanding? Hayley.
I just have a question. Can we try doing a dividing where it doesn't come out with a decimal? It's like 50, oh wait, like 6 over 3. Like 6 to the 10, 20 to 3 to the 10.
So what was the question? What do you want us to do?
6
times 10 to the power of
20.
20 divided by
3 to the power of
3 times 10 to the power of
7. Oh no, 23.
23. Okay.
Now we're ready.
Any responses to that question? No.
Is it 2 times 10 to the power of negative?
So 2 times 10 to the power of
Negative 3?
-3.
Okay. So it doesn't matter if it's a catch.
No.
Cool.
In fact, if it was, I mean, that gives you a whole
Yeah,
number.
I
It's
mean,
great, isn't it? If it becomes a decimal, you just have to do an extra step. So that's
Okay.
easier.
So, whole number.
Okay, right. Can I just sum up kind of what we've done so far then? Currently, what you have done, and in those problems you've done both of the things, you have added numbers in standard form, you have subtracted numbers in standard form, and in that last problem you have multiplied numbers in standard form, and you have divided numbers in standard form. And you've applied those numbers to a problem-solving situation. So there's not an awful lot more to do. That's it really. Standard form is just a way of writing numbers. Alright? So we don't really need to spend much longer doing. Okay. What we do need to do, I guess, is let's find the point at which you feel you need to work. So in your book, right, if you turn to page 131, okay, you will see the page on standard form, and as we go through, it tests all those skills, converting from one number to the other, adding, subtracting, and so on. Okay, there's not an awful lot. If you are very happy and very good, then maybe right at the end on page 134 at the end of the exercise, you can solve those problems. They're more the kind of ones that you need to be aiming for. And if you've done those, you can go to the green pages at the back, and you'll see there are lots of standard form questions mixed in with the surds. You can just have a go at the standard form ones. Okay? So that's page 131 or up to 134. They're on page 144.
What do you do if you're done with green pages?